This podcast is brought to you by the School of Advanced Study, University of London.
Okay, it's a great pleasure to introduce James Hart from the University of Oxford, and he's going to talk to us about Abstraction Reconceived, a dynamic approach to the bad company problem.
Thank you. It's a great pleasure to speak here at the second Logic and Language Conference. This is going to be a talk about logic and specifically about neologicism. So let me start just by saying some very introductory things about neologicism. So in very broad terms, neologicists want to ground mathematical knowledge in abstraction. And I want to see this as kind of involving two claims. They may say other things as well, but they probably want to say something along these lines. So first of all, abstraction principles enjoy a special epistemic status. So here's perhaps the most famous example of an abstraction principle, Hume's principle. So this tells us that the number of x's is the same as the number of y's, just in case the x's are just as many in number as the y's, i.e. the x's and y's can be put into one correspondence. So like all abstraction principles, on the left-hand side, we've got an identity statement, and on the right-hand side, we've got some sort of equivalence statement. In this case, the statement that the x's and y's can be put into one correspondence. And so what's distinctive about the right-hand side of Hume's principle is we can express that in purely logical terms. And then the claim that the neologicists want to make is that there's something epistemically special about this axiom. So something like, as far as we can make sense of these notions, it's analytic and a priori, it's something like a conceptual truth. Perhaps it's not quite a definition, but it's definition-like in certain respects. So that's the first sort of claim they want to make. And the second is that these abstraction principles suffice to naturally recover standard mathematics. So the famous result here is Frege's theorem. And that says in the case of arithmetic and Hume's principle, we succeed in this model. So when we add Hume's principle to second order logic, we're able to interpret arithmetic. So we can translate the language of piano arithmetic in such a way that the axioms and theorems of piano arithmetic become derivable from Hume's principle alone in the context of this logic. So if we can do both of these things, we've done something quite remarkable. We've answered a hard question, or at least made significant progress on it by showing how we might have knowledge about abstract things. The theorems of arithmetic now emerge, suitably translated, as derivable from something like a conceptual truth. But both of these claims 1 and 2 are certainly open to doubt. So let me start by asking, do these abstraction principles enjoy this special epistemic status? So I guess one might worry that if you're entitled to stipulate Hume's principle without kind of substantive prior epistemic work, why can't we just stipulate the piano axioms to begin with? Or some commentators more pointedly might say, well, why can't we just stipulate the existence of God and then let him or her do the mathematical epistemology for us? And in very, very schematic terms, and I'll say something more about this presently, the form of the response is that there's something special about these abstraction principles, which isn't shared by the other bad kinds of stipulation. What I want to say at the moment, though, is, and this will all be very familiar, I think, to lots of you, that we can't expect that kind of story to be applied completely uniformly. So it's certainly not the case that all abstraction principles can be stipulated true without substantive epistemic work. And the reason is familiar in the form of basic law 5. So basic law 5 is perhaps the second most famous abstraction principle. So this tells us that the extension of the concept X is the same as the extension of the concept Y, just in case the very same things fall under X and Y. just in case x and y are coextensive. And in the context of impredicted second-order logic, this is inconsistent. So it can't be true, and it certainly can't be stipulated true without substantive epistemic proof. So in order to defend the view that abstraction principles enjoy a special epistemic status, we need to distinguish between the bad ones, like basic law 5, which don't, and the good ones, hopefully including Hume's principle, which do. And one approach to this problem has to be to articulate some kind of criterion on good abstraction, and recent attempts, which we'll survey a little bit later, include things like being stable or strongly stable or ironic. Second question. Do abstraction principles suffice to recover mathematics? So, in the case of arithmetic, we have a theorem which says, at least as far as interpretation, they do. But what about analysis? And in particular, what about set theory? So there's been some work in both of these fields, and today I'm going to focus on the second question. So do abstraction principles interpret set theory? Well, at least to begin with, our target set theory is going to be second-order Zermelo-Fraenkel set theory with choice, and it's not going to be pure. We're going to allow for new elements or nonsense. So early work here from Boulos was to try and get set theory out of a modification of basic law 5. So the new version of basic law 5 here tells us that the extension of the concepts x and y is the same, just in case they're either both the size of the universe or they're coextensive. And really, this is a limitation of size fix to avoid Russell's paradox. So the thought is that only the concepts which aren't too big are allowed to form sets. So any, and here the standard of being too big is being the size of the universe. So any concept which is the size of the universe is assigned the same dummy extension. And then whenever concepts aren't universe-sized, their extensions are identified and distinguished according to coextensiveness. Now, Boulos shows that once we give a suitable definition of set and member, we can prove a fair amount of second-order set theory from this axiom. So we perhaps don't get quite everything we want, but we get a fair tranche of second-order set theory. Notably, without adding anything, we're not going to immediately get the power set axiom or the axiom of infinity out of it. So this isn't as much set theory as we would like, but it's certainly a step in the right direction. We might hope if we add some further abstraction principles, maybe we'll be able to get the rest of second-order set theory. So I really want to focus today on kind of a tension between these two aims, trying to solve the bad company problem and trying to recover set theory. So it seems that this sort of bad company generates a dilemma. And to begin with, this is just going to be a very crude first pass at the dilemma, and about halfway through the talk, I'll refine it. So just to kind of see the structure of the problem. So suppose we take our condition of being a good abstraction principle to be one of these ones like stable or strongly stable or ironic. The dilemma is this. If we don't have a condition like that, then we fall against the skilla of being too strong to be true. So if we don't impose this constraint on good abstraction, our theory is going to be inconsistent. On the other hand, once we add a constraint of this kind of form, specifically stable or strongly stable or irenic, then our theory is going to be too weak to recover set theory. So it won't be the case anymore that we can prove the axioms of set theory from abstraction principles meeting a constraint. And nu v here is a case in point. So nu v gave the neologicist some set theory, perhaps not as much as they wanted, but it doesn't satisfy these constraints which they impose to avoid the bad company. So nu v isn't stable or strongly stable or irenic. So if we're going to impose those kind of constraints to avoid bad company, we immediately undo the good work Boulos had done approaching set theory. So my aim here is to try and avoid this dilemma. And in doing so, I'm going to give an account of abstraction which is slightly different to what I take to be the account of abstraction which neologicists have traditionally defended. A couple of disclaimers at this stage. So I'm going to sketch how abstraction could render the axioms of set theory true without trouble from bad company. Abstraction raises all kinds of issues, and in many cases, issues which were potentially problematic on the old account will still be potentially problematic on my account. And I won't necessarily, at least one of these will be explicit, but some of these I'll simply be silent. The other disclaimer is that at this stage at least, my aim is purely to see whether the sort of interpretation that is characteristic of abstraction could render the axioms of set theory true. I'm going to make no attempt to answer another question, namely whether anything like this was the means by which we made the axioms of set theory true, assuming that they are. So, to begin with, let's review what at least my reading of what the received account of abstraction is. So for reasons that are going to become apparent, this is going to be called static account. And then after I've done this in section 2, in section 3 I'll look at why this generates the bad company problem in a bit more detail. And then finally, right at the end of the talk in section 4, I'll propose a different account of abstraction, which I'm going to call the dynamic account, and show how I think it can be used to avoid the dilemma. So let's return to this question of why we're able to stipulate abstraction principles without serious epistemic work, or what's special about these abstraction principles. So there are at least two strands to my mind in what the neologicists have written about these. And one is a kind of account of good implicit definition. So perhaps implicit definitions enjoy certain qualities, like being conservative in the right kind of way, or being harmonious, or general, or non-arrogant. And these qualities might serve to distinguish abstraction principles of the good kind from stipulations of the bad kind. The other thread in their thinking is, it seems to me, that there's this something like an interpretive process of abstraction, and this process makes good abstraction principles true, and that's what's distinctive about these abstraction principles. So I'm not going to make any effort to try and see how these two features relate to each other. And I'm going to focus entirely on this second answer. So this thought that what makes abstraction principles special is that there's a certain process which makes them true. So let's start with looking at that process of abstraction. So Frege, in a very famous and much quoted passage of the Grundlagen, introduces what I'm calling abstraction this sort of way. So the judgment, Frege writes, A is parallel to B, can be taken as an identity. If we do this, we obtain the concept of direction and say, the direction of line A is identical with the direction of line B. Thus we replace the symbol parallel with the more generic symbol equals through removing what is specific in the content of the former and dividing it between A and B. We carve up the content in a way different from the original way, and this yields us a new concept. So this idea of concept recarving is, on the face of it, a little opaque and metaphorical. But shortly after Frege writes this, he says something which seems to me to get to the heart of it. So what is it to recarve a parallelism statement as an identity statement? Well, Frege, in the case of directions, says this. In order to get, for example, from parallelism to the concept of direction, let us try the following definition. The proposition line A is parallel to line B is to mean the same as the direction of line A is identical with the direction of line B. So what it seems to me is going on here is we have a certain equivalence statement. So this is the notion of recarving in play. So what is it to recarve it? Well, we take the content attached to this antecedently interpreted equivalence statement, in this case, line A is parallel to line B, and we attach that very content to, let's suppose, an as yet uninterpreted identity statement. The direction of A is identical to the direction of B. And this is how I want to suggest recarving is to be understood in general. So we start off with an equivalence statement, X is equivalent to Y. And that very content is then attached to an identity statement. The abstract of X is identical to the abstract of Y. So before looking at just how that's supposed to be spelt out, two desiderata, I think, are apparent. So let's suppose that before we've done any abstraction, we start off with just the standard interpretation of the logical part of the language. Call that I0. And then one obvious desideratum is that this abstraction ought to result in a new interpretation I1 that makes at least the good abstraction principles true. So to keep things straightforward, our abstraction principles are all going to be purely logical. So on the left-hand side, we'll always have an identity statement, and on the right-hand side, the equivalent statement, let's suppose, is framed in purely logical terms in second-order logic. And, okay, here's a second desiderata. So another thing this kind of reinterpretation is going to have to do, at least if Frege's theorem is to ensure that the Peano axioms come out true under this new interpretation, is to render logic sound under the new interpretation. So two straightforward desiderata, how are they to be met? So suppose we've got the standard interpretation of logical expressions I0 over some domain M0. Just how does abstraction result in I1? Well, this is certainly different in presentation and emphasis to how this is sometimes being presented by neologicists. I hope it's not different in content, but neologicists may want to say something about that in the Q&A. So I take it that what the central kind of recarving for is in S1. So relative to any assignment over the initial domain M0 of the interpretation I0, the content of the equivalent statement X is equivalent to Y is stipulated, or there are stipulations which result in its being the very same content as is expressed under the new interpretation I1 by the identity statement, the abstract of X is identical to the abstract of Y under the very same assignment. A few comments and caveats. So first of all, neologicists are very clear that the syntax here is to be taken at face value. So the left-hand side is a genuine identity statement flanked by genuine singular terms. That imposes a certain constraint on the kind of content that can be in play. So on structured notions of content, there's something in common between the syntactic structure of a sentence and the content of the proposition expressed. And so any two sentences which differ syntactically ipso facto differ in content clearly that can't be the kind of notion of content in play here. I tend to think about this in very coarse-grained terms, just sets of worlds. Neologicists have typically gone for something unstructured but not as coarse-grained as that. And it should also be highlighted at this stage that this is clearly not an interpretation of a certain canonical kind. So the standard way to interpret a formal language, say in second-order logic, is to specify a model. And a model has a bottom-up character. So what we do is we stipulate the semantic values of the simple, typically subsentential expressions, and then we lay down compositionality clauses, and that allows us to determine the content also of complex expressions. Here we're not doing it. We're starting, as it were, in the middle, and just going straight for the content of certain complex sentences. Now, that non-standard kind of interpretation raises a worry. And the worry it raises is, well, if you interpret in this non-standard way, does the syntax remain semantically significant? So we've said that the syntax is what it appears to be, but then there's this further question of its semantic significance. And at a minimum, we need semantic significance to the extent of rendering logic sound. So does this stipulation S1 render logic sound? Well, the answer is both a qualified yes and an unqualified no. So the qualified yes is that for the fragment of the language we've interpreted, there's a straightforward necessary and sufficient condition for the soundness of logic, namely that the equivalence relation the equivalence statement express an equivalence relation. Then we won't have any trouble with the laws of identity on the canonical identities we've interpreted. The unqualified no is that we just haven't yet said anything about the interpretation of any sentences in the new language, in the new interpretation, other than canonical identities. And any interpretation which renders logic sound has to render every tautology true, and we just haven't given any interpretation yet to, for example, everything is self-identical. So the response, which isn't perhaps hugely emphasized, but is what I take the neologicists to hold on to, is that, well, also when we're reinterpreting according to I1 through abstraction, we're not changing the content of logical expressions. So that S1 is to be supplemented then with S2. So the interpretation of logical expressions is going to be static. And this is why I'm calling this form of abstraction static abstraction. So under the new interpretation, the quantifier for all V continues to express universal quantification over the initial domain. And similarly for all of the other logical expressions. Now, although not a huge amount of emphasis is put on this point, it flows very naturally from the neologicist's commitment to absolute generality. So the thinking here is that even before we've done any abstraction, we already quantify over the all-inclusive domain, including in particular all of the natural numbers. And so providing abstraction doesn't make our interpretation any smaller, the universal quantifier will still express universal quantification over this domain. And a second reason to go for something like this is that once we add in S2, then we really do get the desiderata. So this will ensure that logic is sound. Okay, but the trouble is I think these two stipulations or results of stipulations together are what seems to me the source, if you like, of the background. So for what it's worth, it seems to me that each of these are individually innocuous. So clearly S2 is fine. We can come up with a new interpretation where the semantic values of logical expressions don't change. But also it seems to me, S1, if a linguistic community really wants to reinterpret some of their sentences in this non-standard way, I'm not sure we can stop them. What's less clear is that you can have them both at the same time. So the trouble here is that they seem to make conflicting demands on the size of the universe. So let's suppose that the initial universe of I0 has cardinality kappa 0, the new universe of the new interpretation has cardinality kappa 1. Well, consider the case of basic law 5. So the first stipulation is telling us that the content of the identity statement under I1 should be the same as the content of X is coextensive with Y under I0. But now if we've got kappa 0 objects in M0, we've got 2 to the kappa 0 concepts over that initial domain M0. And then S1 demands that each of these be given a distinct object in the new domain M1. So the cardinality of the new domain kappa 1 has to be at least as much as the number of concepts in the old domain, which strictly exceeds the number of objects in the old domain. So the new domain has to be bigger than the old one. On the other hand, if we're supposing that the logical expressions have the same semantic value, we're supposing that the domain doesn't change, and so kappa 1 has to be the same as kappa 0. And we're going to get similar trouble whenever the equivalent statement on the right-hand side is finds expression inflationary on the initial domain. So whenever the number of equivalence classes generated on concepts by the right-hand side exceeds the cardinality of the initial domain. So for example, we can't, if it turns out that the initial all-inclusive domain is finite, we can't stipulate Hume's principle, because that would demand for there to be more numbers than there are in the absolute domain level. Okay, so let me now come back to look at the bad company problem and why I think that a certain style of standard response isn't very satisfactory. So we need somehow or other to rule out these inconsistent abstraction principles like basic law 5. A very first try, which now looks immediately hopeless, I guess this might have been a first try prior to 1902, is to demand that the equivalent statement expresses an equivalence relation, but that's just hopeless because basic law 5 meets that condition. Although this condition, I guess the only thing is it directly drops out of the neologicist's account of abstraction. Okay, so we might try and do better. Well, a natural second try, which also, as we all know, isn't going to work, is that we demand that these abstraction principles be satisfiable. But for a long time now, we've known of examples of pairs of abstraction principles, each of which are satisfiable, but which are jointly unsatisfiable. So George Boulos gives the example of the parity principle, and this is only satisfiable on finite universes. But Hume's principle is inflationary with all of those finite universes, and so unsatisfiable. So the two together can't be satisfied even though each of them meets C1. So further tries, one strand of thinking has been to try and regiment some sort of conservativeness idea. So very roughly the thought here is that good abstraction shouldn't say anything about the non-abstracts. So we shouldn't have our abstraction principles yielding new consequences for old ontology. And this sort of idea has been regimented and refined in a number of ways. So one natural way to go is this notion of field conservativeness. So if, together with the abstraction principle, the theory, or what the theory says about non-abstracts, entails some conclusion about non-abstracts, then that conclusion should have already been entailed by the theory alone without the abstraction principle. A little bit stronger, we might demand not only is the abstraction principle field conservative, but also jointly satisfiable with any other field conservative abstraction principle. And then there's also been a number of more immediately model theoretic adequacy conditions. So we might say that, well, what's good is if the abstraction principle is unbounded, so it's satisfied in arbitrarily big domains given any cardinality. You can always find a bigger cardinality in which it has a model. Or if it's stable, so there's some threshold, and above that threshold cardinality, it has a model in every larger cardinality. And recently, Roy Cook has tried to defend as an adequacy condition strong stability. So not only is there this threshold, so not only is it stable, but also below this threshold, it never has a model. So if we're going with this sort of adequacy condition, we run into the dilemma I gestured towards right at the beginning. So here are the various proposed adequacy conditions. So as we move down the table, they become more restrictive. And in the case of purely logical abstraction principles like we're considering here, unboundedness matches up with field conservativeness, and stability matches up with ionicity. Now the Skinner side of the dilemma is familiar here. So if we have sigma c for just the second order theory, which includes all of the abstraction principles that meet the constraint in question, and we take our condition on good abstraction to be any of the ones above the line, satisfiable, unbounded, field conservative, then we wind up with a theory which is inconsistent. And the example here, which is familiar, I imagine, is with abstraction principles. He comes up with pairs of abstraction principles which meet these conditions, but are not jointly satisfiable. And tweaking the example a little bit, we can come up with an example where they're inconsistent too. So the natural response then is to go with one of these more restrictive conditions. You know, if we're admitting too many abstraction principles, one of the theory is too strong, let's be more restrictive. And the trouble is, if we go that sort of way, then we wind up being too restrictive. So the start of the problem is if we go with one of these stronger these stronger criterion on being a good abstraction, like stable or strongly stable or irenic, then we're no longer able to prove the axioms of second order set theory. So what's going on here is just a simple cardinality problem. If you've got a set of stable abstraction principles, that set will also be stable. So there'll be some threshold where it has a model in every larger cardinality. But second order set theory doesn't share that property. So we can always find arbitrarily large cardinalities where it lacks a model. So just take one of those cardinalities above the threshold, then the abstraction principles have a model, but set theory does not. And that's also true for a theorem of second order set theory which is much weaker than the whole theory, namely the theorem that any countably many things, there's a set which has precisely those things as its element. Now, I think this theorem was in not quite this form. This is a very immediate corollary of a theorem due to Gabriel Iscaiano. But I think as it stands, the neologicist has a natural response to this apparent weakness in their theory of abstraction. Namely, just because it doesn't prove the axioms doesn't show that it doesn't interpret. So it remains the case that there might be some translation where when we translate the language of set theory into the language of abstraction, we can then, so understood, prove the axioms of set theory. And to make the point a bit more strongly, actually this scenario is precisely familiar from the case of arithmetic. So it's just not the case that Hume's principle proves the axioms of arithmetic. And indeed, one way to see that is for exactly the cardinality reasons which are at play in this cardinalist group. So Hume's principle is strongly stable. It has a model in any infinite cardinality. Peano arithmetic only has countably infinite models when formulated second order. So any uncountable model of Hume's principle can't be a model of Peano arithmetic. So therefore we can't prove those axioms from Hume's principle, but we can interpret them. So once we give a translation from the language of Peano arithmetic into the language of abstraction, then so translated, the axioms are theorem. Now, there is, however, a disanalogy between the case of arithmetic and the case of set theory. So, in the case of arithmetic, our quantifiers are tacitly restricted to natural number. So when you say for all x phi in the language of Peano arithmetic, what you mean, of course, is that every natural number. And this tacit restriction comes out explicitly in the translation which interprets Peano arithmetic. So for all v phi under the translation comes out as for all v, if it's a natural number, then phi. But this isn't the case in set theory. So in set theory, under the intended interpretation, the quantifier is unrestricted. It ranges over, at least in the case of set theory with G elements. This wouldn't be the case in pure set. Because in set theory with G elements, the quantifier ranges over every set and every non-set, everything. And so if we want to capture the intended interpretation of set theory with our translation into the language of abstraction, we ought to respect this unrestricted. So when we translate for all v phi, that should be translated under T as for all v, and then the translation of phi under T. Okay, and when we have this additional zero-ultimate unrestrictedness, now we can come back and formulate the dilemma in full stroke. So here's the problem for this particular stranded response to the bad company problem. So here are our familiar conditions on good abstraction. The worry about the ones above the line is that there is ultimate theory which is too strong to be true. So if we take C to be satisfiable or unbounded or field conservative, we wind up with an inconsistent theory. If we go the other way, we wind up with a theory which is too weak to interpret set theory when set theory is given unrestricted generality. So if our condition is one of the ones below the line, stable or ironic or strongly stable, and the translation is unrestricted, so we translate for all v phi as for all v the translation of phi, then we're no longer able to prove the translations of the axioms of set theory, nor for that matter are we able to prove the translation of the theorem, any countably many principles. So there are two sorts of ways one might go, of course. One would be to look for a new adequacy condition. So I mean, all of these results just trade on the particular adequacy conditions which have been proposed. Others may well and have been proposed. Maybe we could that route. To my mind, although I won't go into it, none of those have really worked either. And so I think it's worth at this stage pursuing a slightly new approach altogether. So thinking about abstraction in a slightly different way. So let's turn finally and quite briskly to the proposed alternative. So this is the dynamic account of abstraction. And it differs from the static account in two key respects. So let's have our initial interpretation again I0 over some universe M0, and then abstraction results in this new interpretation I1. So the key difference is that we no longer suppose that the universe need remain static. So on the static account, remember, we thought that the semantic value of the quantifier should remain the same. On the dynamic account, we allow that the new universe may be strictly wider than the ultimate. So we give up this assumption that we had absolutely everything in the initial domain, and in going through abstraction, we may come to a quantifier which quantifies over a strictly wide domain. So this releases the cardinality pressure, which led to trouble in the case of abstraction principles like basic law 5. So if the initial universe at M0 has kappa 0 many members, the new universe has to have 2 to the kappa 0 many members. But then that's only going to be a problem if we think those two universes are the same size. So on the dynamic account, we simply allow that when we abstract on coextensiveness like that, we wind up with a strictly wider new domain. And then once we allow domains to become bigger in that sort of way, we can iterate the process. So in generating new sets, we also generate new concepts of those sets. And so starting, again, consider the case of basic law 5, starting with kappa many objects and 2 to the kappa concepts, one round of abstraction will give us 2 to the kappa objects, a second round of abstraction, 2 to the 2 to the kappa objects, and so on. So in very broad terms, let me sketch how this is working. So this recarving idea remains very central to this account of abstraction. But we allow it to be iterative. So so we've now got this sequence of interpretations, I0, then I1, and I2, resulting from successive rounds of abstraction. And in each of them, whenever beta is an interpretation later down the sequence, the content of the identity statement under the later interpretation is going to be exactly the same as that of the equivalent statement under the earlier one, for any assignment over the domain of the earlier interpretation. And once again, this has a straightforward, necessary, and sufficient condition for not running into conflict with the laws of identity. Namely, we have to always express an equivalence relation, and under any two interpretations, those equivalence relations have to agree on their common domain. Now, once we've put down S1 star, the way we're going to render logic sound is just by distributing coarse-grained contents in the right sort of way. So here we run into an issue which was an issue before and remains an issue, namely the Caesar problem. So if we want to interpret all of the sentences, that's going to include non-canonical identities like the set of the empty concept is identical to Julius Caesar, or the abstract of X is identical to Y, and we're going to have to say something substantive about how these contents are distributed. And I shan't now. But once we've solved the Caesar problem, it then becomes relatively straightforward to assign contents to all of the other complex sentences in a way which is going to render logic sound. And then finally, right at the end, once we've given unstructured contents to all of the sentences of the language, then semantic values are going to be recovered as subject to the constraint that they return compositionally the intended contents. So, one thing that you immediately lose, of course, if you do things this way, is that the static abstraction principles aren't going to be true anymore. Because we're not coordinating contents of identity statements and equivalent statements under the very same interpretation. Rather, on the dynamic account, the identity statement is coordinated with the equivalent statement, where the identity statement is under strictly later interpretation. So to express the result of dynamic abstraction, one way to do it is to move to a slightly richer language. So as well as the language of second-order logic and all of these function symbols, I want to suggest that we add some modal operators to the language. So these behave in a fairly tense-like manner. So the top one we can read is, it would always be the case that psi, and that's going to be true under an interpretation I alpha, just in case psi is true under every later interpretation I beta in the sequence. Similarly, second of all, it was always the case that psi is true under I alpha, just in case psi is true under every earlier interpretation in the sequence. And with these two primitive modal operators, we can define some other ones. For example, it's always the case that psi is defined in the orthogonal way. And then we can define the kind of dual possibility operators in the standard way. Now, the thought is that when we're working in this setting, abstraction principles are going to look slightly different. So because we're coordinating the content of identity statements with those equivalence statements, but the identity statements are at all later stages, we're going to add a modal operator to the left-hand side of the abstraction principle. So it's telling us that if and only if x is equivalent to y, then at all later stages, the abstract of x is identical to the abstract of y. And then the second abstraction principle, or dynamic abstraction principle, if you will, is telling us that this is the only way that we come to abstract. So at any stage in this process of successive reinterpretation, any object available, if it's the abstract of some concept at any stage whatsoever, then it must have been the abstract of some concept we had available before. Okay, so that's very sketchily a brief account of this slightly different approach to abstraction. Let me just conclude by revisiting the Skiller and Charybdis problem I posed for the static account. So let's have sigma star C star as just the dynamic theory which comprises second order logic. Some modal axioms to govern our modal operators. These will ensure, in particular, that the series of stages are a serial well order and more than that. I'll come back to that. And then all of the dynamic abstraction principles which meet our adequacy condition. And then the natural first try for an adequacy condition is just the one which we required to make the laws of identity come out sound, namely this idea that the equivalence statements express equivalence relations which agree on their common domain. Now, in the static account, when we did the analogous thing, we wound up with a theory which was too strong. In the dynamic account, this is going to be consistent. So there's a straightforward Kripke model which will prove the consistency of our theory. What about the question of strength? Oh, I should remark that basic law 5 is ruled good. The dynamic analog of basic law 5 is ruled good by our adequacy condition, but the dynamic analog of basic law 5 isn't problematic. In fact, not only is it not problematic, it can be put to work to recover a substantial tranche of set theory. So let's return then to the Charybdis side of the level. So in the static account, remember, when we imposed some of the constraints available to avoid inconsistency, the cost was that we then got a theory which was too weak. We were no longer able to interpret set theory in its full intended generality. In the dynamic case, we can still interpret set theory in full generality, subject to some constraints and caveats, which I'll now briefly enumerate. So 3 comments about this interpretation. So the dynamic theory does interpret second order set theory. The version of second order set theory is potentialist in a certain sense, and full generality is going to mean something, is going to come out in a slightly different way. So remember that in the static case, where we take the initial domain M0 to contain absolutely everything, then what we need to achieve the intended generality of set theory is just to leave the unrestricted quantifier unrestricted when we translate from the language of set theory into the language of abstraction. In the dynamic account, that would no longer be enough. The reason is, at each stage in this process of reinterpretation by abstraction, the quantifier always ranges over a domain n alpha, say, which is less than all-inclusive. So if we just let our quantifier range unrestrictedly over that domain, then we're not going to succeed in generalizing about every set in the cumulative hierarchy, every set formed at some stage or other in this process of abstraction. And so to achieve the intended generality and really talk about not just the sets we have available now, but the sets that might be formed at later stages in the process, we need to attribute some tacit modal content to the non-modal language of set theory. So when we translate from the language of set theory into the language of dynamic abstraction, we're going to prefix our universal quantifiers with boxes. So for all v5 is now being read that at any stage in the process of abstraction, it's the case that all v and then the translation. So when I say that it interprets ZFCU to in full generality, what I mean is that when we translate it in this modal way, we can prove the axioms of the second order set. The second caveat concerns the second order quantifier. So the picture which emerges has a kind of potentialist character. So in the case of the static picture, we've got a single universe which has everything in it. And the cumulative hierarchy sits within this all-inclusive universe. And so we can have a full rank of concepts on top of the set theoretic hierarchy. If you like, a full rank of classes on top of all sets, identifying classes or concepts. We're not going to have that in the dynamic or potentialist. So here, the set theoretic hierarchy is spread out across a number of domains. And although over each of those domains we do have a full rank of concepts, there's no full rank of concepts over the entire hierarchy V. And the result of this is that what gets interpreted has to be a version of second order logic where we restrict second order comprehension. And in particular, we're going to restrict second order comprehension to set-sized concepts. Now, unlike some restrictions of second order logic, this is still a pretty strong theory. So this is still going to be enough to recover all of first order ZFCU. But we don't recover all of second order ZFCU with unrestricted impredicative comprehension. And my final remark concerns two important assumptions hidden away in the logic. So first of all, if we want to get choice out, I see no alternative than to put choice in. So choice is going to figure in a suitable second order formulation in the logic. The second is that this process of iteratively reinterpreting the language according to abstraction is only going to give us sets of infinite rank if we repeat it infinitely many times. So if you start off with a finite initial domain, it doesn't matter how many finitely many times you iterate basic law 5, you're never going to break finitude. So we need some strong assumption about how far this gets iterated. And that assumption can be framed within the modal logic by framing reflection type axiom as a modal schema. But one thing which becomes very clear is that, well, this has important ramifications for what's going on behind the scenes. So I haven't tried to address at all today the question of how we, as ordinary language users, might have done anything. But if one went on to give such an account, it's very clear that if we're going to get up to sets of infinite rank, this isn't something which we do one step at a time. So if there's some way in the style of dynamic abstraction of coming to sets of infinite rank, there must be some way of jumping lots of steps at once. Okay, I think I'll leave it there. Thank you very much.
So you put me back on the bottom of the list.
Okay.
If there's
Keep your hands up.
And the inflation stuff seems to be a big motivator for moving over to dynamic abstraction. And there are a couple of kind of worries I have about the way that it's doing it. So, just find the slide. Sorry. So, first sorry. So this one. Oh, right. So, firstly, on the static approach, it's kind of an important bit that the universe of your interpretation ranges over absolutely everything. It's kind of unclear what sense it would make to say that that has a cardinality anything. Because if it ranges over absolutely everything, it ranges over absolutely all sets. So certainly the domain can't form a set. So that's one worry. And then the second worry is that it's kind of unclear how inflation is going, how it can actually be a kind of diagnosis of the bad company problem anyway, because to get the kind of Cantor's paradox kind of thing going, you need to assume full second order set theory. Sorry, full second order semantics for your second order logic, but basic law 5 is inconsistent just at the object language level. And the object language you can interpret your second order domain as ranging just over definable subsets of your universe. And there are going to be as many of those as there are members of your universe, assuming your universe is infinite. And so you still get this contradiction, even if you don't have these cardinality considerations.
I mean, I think really, you're totally right, of course, about set cardinals. So, if we frame this in kind of terms of set cardinals, this is no more than suggestion. But the problem is suggesting more is simply that there are more, to speak loosely, concepts. So, let's quantify over the all-inclusive domain. There are more concepts over this domain than there are objects in it. And to truly interpret basic law 5, there would need to be no more objects in that domain than there are. But we can sanitize those presumably instances of misspeaking in a higher order language. So we can naturally express that there are more concepts than there are objects in a higher order language. And then we don't need to muddy the water by bringing in set cardinals.
No. I guess that sort of answers the second issue as well, but it leaves a puzzle, I guess, for how you can have a second order, the structure of a second order language where there are as many which satisfies full comprehension, but there are only as many concepts as there are objects.
But I put it to you that is a kind of quirk of the expressive resources of the language. And so if you move to a more expressive language, you would come up with further instances of comprehension which weren't covered in the initial. And so I take it that the thought behind full comprehension is really that for any zero or more things, there's going to be an extensional concept under which those things are. And so if you think you can make sense of, if you think you can really make sense of second order quantification in the sort of way that makes sense of the kind of full power set, which I take it that the neologicists do, then there really will be more concepts than there are.
Yeah, I mean, you say, what does this mean for us ordinary language users and being, an ordinary mathematician? I sort of keep wondering, because you actually keep splitting between set theory and mathematics, and personally, I'm prepared to let set theory go hang if it gets us into all this trouble. And also, my other suspicion is that this looks very similar to an awful lot of stuff that constructivists have been doing for a long time. I mean, sort of stuff with universes and sort of dynamic interpretation of logical constants and all that sort of thing. So, I have a sort of rather curious and non-hostile why question. And also, since you keep saying the neologicists, so you're presumably not a neologicist, so what's the, what's your own position on this?
Thank you. Let me try and take those points in order. So first of all, letting set theory go hang. I guess you suddenly, if this approach is going to account for not just set theory and mathematics, and you're right, I was slipping on it. Then you would want a similar story about other branches of mathematics too.
Oh, sure.
And that you might expect that. And so suddenly we sort of know how we know how it's going to go in the case of arithmetic.
Yeah.
We maybe with kind of less naturalness know how it's going to go in the case of analysis. And we might try and pick things off case by case.
Yes.
I guess there are still some set theorists out there still doing set theory. And that, that's still a substantial part of the mathematical community. We should write them all. And so, I want to recapture what they're doing as well.
I think the real concern behind that was to say that, the whole enterprise is sort of very foundationalist. This is, the philosophy of mathematics seems to remain very foundationalist. I mean, there's a sort of more general task of the philosophy of mathematics, which is just basically to illuminate the nature of mathematics. And one could maybe argue that, the sort of concentration on foundationalist questions has led to, mathematically rather special work of this sort, and has, directed attention away from a lot of the stuff that mathematicians also do.
I mean, you're certainly right. So this is only directed at certainly very narrow perspectives, and there's obviously a lot more to what mathematicians do than this kind of thing is going to give us any insight into. So, I guess one point which I think is worth making is it's not just mathematicians to whom mathematics belong.
Yeah.
And I don't really so much have philosophers in mind straight away, but if you think about kind of the ordinary, person's use of numbers,
Yeah.
and people make all kinds of, and they don't have a mathematical theory in mind, but they make all kinds of inferences where they bring in numbers, accountants or whatever. And it would be nice, I think, to have an account of how those inferences could be knowledge sustained.
Yeah.
And so one thing which is a very natural move to make is to go from phi holding of x to x being a member of a set of phi. It's or x having the property phi. And it's the kind of thing ordinary language users do all the time. And of course, if we look at this through the lights of something fairly static, that's going to be inconsistent pretty quickly. And something like this approach might speak to how that kind of inference, which we seem to make all the time, could be knowledge preserving. At least, we made the very first step. We've shown that provided there's this shift in parameter, we need not run into inconsistency. Thank you.
Yeah.
Yes, I wonder whether you could provide me and indeed the rest of us perhaps as well with a bit more help understanding the metaphysical implications of the differences between the static and the dynamic versions of neologicisms. So I think I once understood the static version. We have these quantifiers ranging over absolutely everything. And you were giving us a very different picture on the dynamic version of the theory. So you started out talking in unashamedly temporal terms, you know, the initial universe, the new universe, generation of new sets, the universe getting bigger, all these verbatim quotations from. And as I understood it, that was not in the end to be taken literally. So this was going to be superseded by the modal interpretation. Is this the idea? That
That's right.
yes. So we've got this, in the end it's going to be cashed out in this so-called potentialist picture. I just wonder whether you can just tell us more about the basic modal notions that are implicit in that picture. I feel a need for explanation of them. Yeah.
Absolutely. So I think a good place to start is logical possibility. So suppose that you're on board with logical possibility. And what's notable about logical possibility is it's not circumstantial. So we're not interested in shifts in circumstance, we're interested in shifts of interpretation. And it's shifts of interpretation which are the concern of the modal operators that I have in mind too. So all of this kind of temporal talk of the universe becoming bigger. It's not the case that if we just sit at a fixed interpretation parameter and let time progress, the universe of pure sets is going to get any bigger. But there's a different sort of shift, not from one time to another, but from one interpretation to another. And it so happens that those interpretations perhaps one might be had by us later in our time, but there's nothing essential to that. And so this modality of the kind I have in mind is like logical modality insofar as it concerns shifts of interpretation, but it's more constrained than logical modality. So rather than being interested in any arbitrary reinterpretation of non-logical expressions, I'm only interested in those which result from this reinterpretation process distinctive of abstraction, namely this particular kind of coordination of content.
Good. And so that's going to give you the justification as to the particular requirements you place on the relevant relation in the predictive model.
That's right. So that will give you the modal logic insofar as I mean what the strong assumptions in the modal logic are is iterating lots of times.
Yes.
So that assumption is definitely one which is open to question and all needs to be said about.
Yeah. But things like seriality are going to come out of the constraints on the reinterpretation. Is that the idea?
Well, I mean, seriality comes out. Seriality just comes out of the fact that there's always a next interpretation.
Yeah. Okay.
So we're just repeating this process again. So that's already an assumption about how many times we're iterating.
Yeah. Good.
And then kind of constraints like the universe not getting any smaller. So we'll have the converse Barclay formula in our logic reflecting that fact.
Yeah.
And that comes out of how this interpretation works.
Yes. Thanks. So that's helpful. Thank you.
Okay. I have two sort of tiny technical questions first, and then. So am I right in thinking that if you just have basic law 5 alone and not any of the other C-star acceptable principles, that you get everything?
That would be enough to interpret set variabilities potential.
Okay. The other thing is that this, am I right in thinking that this will, on that interpretation of the second order quantifiers, you will not get global choice?
I shouldn't have thought so.
Okay.
So there's not going to be a well ordering of the universe, for example.
Yeah, because all well ordering.
There's no concept big enough.
Yeah. So the
that's a little stronger.
The sort of I have a couple of substantive questions, but I'll just ask the main one, and then maybe you can put me down later if there's time. About the induction on the stages. And the assumption of basically getting enough to go on and on. I'm not So there are two ways that you could think about this. You could think that you're doing the induction directly on the stages. Or you could think that the stages are indexed by ordinals on some anterior account of ordinals that you have.
When do you say doing the induction on the stages?
I mean, you're appealing to transfinite induction in the meta theory. That's what I mean. That to get the monotheoretic results that the structure that are going to enable the structure of the modal operators to behave the way you want.
So you mean in the consistency group, we're using transfinite?
Yeah. Okay. And I'm just curious. Actually, to some degree, I think if you're only using it for the consistency result, it may not matter because you're not intended to. I mean, my question was sort of if you want to show that that holds on the intended interpretation. Then it seems in the first account you're not even going to have the resources to talk about the functions between class size things that you need to make the claims about the domain because you've restricted the second order quantifiers. And on the second view, in which they're sort of indexed by something that's independently given, it's unclear what that principle will be because ordinal abstraction principles, which would be consistent dynamically, if you wouldn't run into the Barali-40 issues, but they wouldn't like guarantee any stage beyond omega.
So I think for the purpose, so I guess it's going to be a theorem. So transfinite induction formulated in first order set theory is going to be, its translation is going to be proven by these axioms once you make these kind of strong assumptions about iteration. So that much recursion is going to be available. And that's all we need for the consistency proof. So the consistency proof will happen in first order ZSC.
Okay, yeah. So I mean, I think there's an issue about understanding the iteration, but it's not perhaps the way that I formulate it. But anyway, we can come back to that later.
Question.
Yeah, I've got a big question. I very much enjoyed the talk, by the way, and there's lots to think about. I'm wondering what the epistemic game is. I mean, for me, the neo-logicist project is an epistemological project. It's a Euclidean conception of mathematics, with epistemic good flowing down from certain basic principles into more and more powerful theories. And the static version of the program founders on, I think we know, since this kind of founders on infinity and power. There seem to be no independently creditable abstractions. Doesn't get over that hurdle. Seems to me we still have the hurdle, because you seem to be a meta theory, and you just at the end towards reflection principles, and the question will arise what credibility they have. But we need some antecedent theory of the possibility of iteration of dynamic abstraction, and presumably a theory of the ordinals to go with that, to count the stages which are allowed to go through. And I'm not sure where all the epistemology of that background theory is coming from. There seems a way, well, tell me, have we made any progress on the epistemic project? Or is it simply that we have a convenient way of finessing the bad company issues?
So it's not immediately clear to me that we need a prior epistemic handle on a theory of ordinals to get any knowledge out of it. So I think this is very much kind of, this sort of account is very idealized. And I, although you may not agree, saw that as a feature in the more static account too, insofar as presumably the way most people come to arithmetical knowledge isn't via deduction from logical
Indeed.
maximum. But it provides, as it were, kind of a safety result that, okay, this will be one way to come to mathematical knowledge, and then we can start looking at how people in fact do that. And I think the root of mathematical knowledge on this kind of account, one natural way to do it is to look at inferences. So inferences from, for example, the right-hand side of Hume's principle or the right-hand side of basic law 5 to the left-hand side. Now, on the dynamic account, in some cases, we're going to have to make sense of an idea of accommodated inference. So if you go from the right-hand side of basic law 5 to the left-hand side, and we assume, as it were, that the interpretation parameter on both sides is at the same level, then that inference can't be knowledge sustaining in all cases. And the very tentative at this stage thought might be, well, you know, there's some pressure through accommodation to say things which are true. So if we say something, parameters are, you know, not necessarily, but there's some pressure for parameters to be chosen that we speak truly. And if these different interpretations are available to us, they're one of the parameters that might shift. So in moving from the right-hand side of basic law 5 to the left-hand side, in some cases there may be upward pressure to move from a lower interpretive parameter to a higher interpretive parameter. And the thought would be, well, if that sort of move is then knowledge sustaining, so that if you know, for instance, that the x's and the y's are coextensive, and then you perform this inference at stage alpha, say, and you perform this inference, you then come to know that what is expressed by their sets are identical, and the next stage comes out, you can know that too. Then we're starting to get some knowledge without you having to yourself have any theory of iteration. And you can iterate that process by making a sequence of inferences. And you will come to kind of successively more and more knowledge about sets. None of that, however, is going to break out of the finite graph.
Yes.
So how could it be the case then that we break out of the finite graph? And again, very tentatively, and I need to think a lot more about this, I think one natural way to go might be, well, if, you know, there is the interpretation above all the finite graphs, so the first infinite interpretation, how could we target that interpretation? Well, one thing to do might be to commit ourselves to a claim which would only come out true if we moved our parameter up to that first infinite level. So we might kind of subscribe to some kind of closure principle, and perhaps this is what the set theorists did. You know, so we state the axiom of infinity. That's only going to be true if we go at least up to level omega plus 1. So accommodation kind of pushes us up there, and that sort of inference could be valid too. But like I said, this is all very tentative, and I need to think about it a lot more. That's just a start.
Right. I mean, there is a difference in the arithmetical case. You know, you rightly observed that no one gets to know basic arithmetic by deduction from Hume's principle.
Yeah.
And it actually raised the question what Frege thought he was doing. You know, what is the philosophical interest of this arcane deduction? But it's different with set theory because there is, I think, a significant issue whether we, properly speaking, know the fundamental principles that generate the paradox. You know, what states of these are they, properly speaking, viewed as item? So there's more pressure, if I was giving an abstractionist recovery of this. So yes, there is indeed a route into knowledge. You know, here's a way you can actually come to know, interestingly, that these principles hold. And it seems to us, from what I've so far heard, that the dynamic view, for all its advantages, takes us no further forward with that issue. Maybe that's a bit harsh, but that's...
I think that's a little bit. So I think one of the upshots of this talk was meant to be that on the static count, not only is there more to be said, but within the confines of a solution to the bad company problem of the sort that we know to be available to us, no more could be said. So we've got a negative result saying you can't interpret set theory within the confines of that kind of solution to that company. Okay, so that's definitely not conclusive. Perhaps we might come up with a different sort of solution to that company, but absent that, we have a negative result in the static case. We don't have any such negative result in the dynamic case, but definitely more needs to be said to convince myself and everyone else that we can say something positive.
So it's linked to the previous question, I think. So I was just trying to clarify your last point. I wasn't clear if the iteration of abstraction you think is an issue for you and not for the static theorists because of how we actually do this or whether we do it or not. Do you think you have got an extra problem because of your theories just for everyone in general?
So the static account doesn't have any problem with iteration because you only do it once.
And so that's what I thought. So, but I think it needs to be an issue for you because there's already some kind of analog in language learning anyway. There's some infinite leap, you might think. That's already going on. There's already these rules we kind of latch onto, and it's mysterious, and so like that's already been noted and dealt with. So you don't have to deal with that.
So I mean, I certainly agree insofar as that you don't need to know anything about the theory of ordinals to make iterated inferences. You might need to be fairly mathematically sophisticated to say the sort of thing that might push you up to an infinite level.
I guess it was more generally like I thought you were saying there's some issue with how we do this, particularly because it's an infinite iteration. Because it's infinite, but we're already doing that anyway in language learning. You might think so. It's not an issue for you.
So I mean, what we presumably can't do is start off with domain M0. We then kind of do basic law 5 style inferences, which pushes up to domain M1. We then repeat that, go to domain M2, and then repeat that countably many times to get to. We can't do that.
Yeah.
So there's got to be some step which isn't just the inference from the left-hand side to, right hand side to the left-hand side, which might push you from a finite stage up to infinite stage. And if you want all of set theory, you're going to have to, go much bigger than count echoes.
Yeah.
So we started a bit late, so I guess we have 5 more minutes. John,
So I'm wondering if there's an issue of a kind of revenge thing happening at the top when you do this interpretation of fully general quantification. So at the stage level, there seems to be a couple of things that you need to be doing. So firstly, you need to be having this kind of picture of non-standard interpretations being allowed. You don't give them this Haskell way because you wouldn't be able to pick out the domain of the domain of those. And secondly, it looks like your second order domain has to be kind of getting generated automatically. So you didn't say much about this. So when you iterate up to the next stage, you somehow need your new concept. So they need to come. There needs to be some kind of automatic mechanism to get your second order domain.
Some kind of mechanism.
Yes, some kind of mechanism. So then, when you interpret the fully general quantifiers at the end in this modal way, given the kind of allowance of non-standard interpretations, this looks like an interpretation of the quantifier. So it also looks like if you've got this mechanism for generating from an interpretation of the quantifier, your second order quantifier, you've got full comprehension. Somehow gets generated in the same way. Whatever generated in the earlier stages looks like it might generate it here.
That's perhaps the point where you might try and get off this particular train of thought. So when you're generating concepts, you're doing it from objects which are all available at the same stage.
So what does it mean to be all available at the same stage? We've got an interpretation of a quantifier now. So if being available at the same stage means you've got an interpretation of your quantifier, which ranges over that, then at this kind of final stage of doing the general, getting the fully general quantifier, you have an interpretation of the quantifier here.
Well, I mean, do you have an interpretation of the quantifier? So we have something which is simulating, if you like, absolute generality. And it's a combination of a modal operator and a quantifier. But it's functioning differently semantically to how a quantifier is functioning. So the same logical rules.
How you cash out the functioning semantically differently, because if that's going to have to presuppose. So the giving up of having to give semantics non-standardly will kind of mean that you can give a semantic story for one extraction in many different ways. So it might be one way of giving the semantics to this fully general quantifier is the way that you initially give it in terms of modality. But then once you've already got this interpretation, well, maybe you can now use that to give the semantics essentially homophobically, and it looks kind of passing, it looks like you've got all the objects there at once. And then if you've got the stage, well, can you abstract on that?
No, I do feel the course of this kind of thing. So I think either, one then needs to say rather a lot more about and this is going to be part of, I guess, fleshing out this account exactly what's going on. So exactly what are we doing when we establish full second order quantification over time? Are there constraints under which we can do that in the cases I say we can, but can't in the cases you say we might be able to? If not, what's the upshot? Well, if not, I guess the upshot would be that this modal operator is, if you like, indefinitely extensible in the same way that we've got the quantifiers might be. And not only can you make the domain bigger, you can make the sequences of stages longer. And of course, the cost is that you lose absolute generality for these modalized quantifiers. It's not the case that we're ranging over, in some yet stronger sense of possibility, every possible set yet, because we could have made our sense of possibility. No, I do feel the force of that.
One final question?
Actually, it's already covered.
All right, so maybe I've used my position as chair and I ask the very last question. Precisely on this. I mean, there is an idea in finding in semantic paradoxes and in conceptualistic paradoxes that absolute generality is the source of the problem. So to what extent would be the case study, and to what extent do you think that's something right in that idea? I mean, what do you think?
So, it's very sensitive to what you mean by absolute generality. So one thing you might mean by absolute generality is that there's a domain with everything. Now, domain, if we're going to take the friends of absolute generality along with us, it better not be a set or class or collection. But some things, so one formulation of absolute generality I think absolutists quite often might be friendly to is this idea that there are some zero or more things, and they comprise absolutely everything. Or if you want to do it in concept terms, there's some concept under which absolutely everything falls. So if you're happy with that kind of second order or plural way of cashing out this notion of absolute generality, then that's something which will hold on the static account and fail on the dynamic. So there won't be any zero or more things under which absolutely everything, i.e. box for all, fault or are right. And so in that sense, you can see the potentialist account being one way to reject absolute generality if you don't understand that too well.
Thanks. Well, we should thank James for an excellent